4, 3, 2, 1. Hello, everybody. I assume I am streaming by this time. It seems like it needs a nice, generous countdown from 10 to get to the point where I am streaming. So I'm from Gryffindor today, although I might be more accurately aligned to Hufflepuff. Anywho, back from screen 7 all the way over to not my journal. You can see I'm in the point where I pick up my best little bag of tricks. I needed a one-liner for loading something out of a file. You can see this is my bag of tricks at the bottom of my journal. If I hit G semicolon, it'll be where I was last typing, and you can see where I'm telling you I'm going to be doing crawling with Python. So almost any research these days into crawling with Python will tell you to get one of those libraries to do all the work. You can see that I'm just pushing up my last stream where I had added a num argument to the SERP function of Pipulate. Pipulate has a SERP function. The SERP function has a num argument that tells the number of results per page that you're asking for, which I set to 100 now for typical work, and immediately pickle to local storage so that I don't have to execute that query again. On this next step, we are going to be visiting a page found in those search results and querying for all the on-page links. I just did a refresh on my YouTube page to see that last video come live. It doesn't have a thumbnail yet, but it does look like it's there. So forget about that for now. This is just a little bit of the overhead. Oh, that's jumping ahead a little bit. We're in the Python SEO directory where we just created the SERP_refine, SERP_scrape. That's where we're going to be doing our new work. That goes all the way to the left. Ooh, SERP_scrape. Oh yeah, no, that was our original file. We're all done with that. File. Closing hole. The word scrape made me think crawl. Different project. Technically, the words can be interchanged, but I just did this SERP_refine, and we're through with that as well. Close and hold. So we're back in that directory. All those have quit out. You can see the project so far has been Hello World, Persistence, doing the original SERP scrape, then the SERP refine. Now we are going to do another new Python 3 object or Python 3 notebook. And creating that nickname right away is very important. So I'm going to pick one right off the bat to sort of give this its identity. This shall be a crawl. Nice and simple and straightforward. Now that other file you saw there, Speed Checker, is one of my past life projects. One of the most recent times I had to do anything crawl-like, where I was like, oh, just let me just grab the links on the page. I got the on-site links. I'm going to actually be switching this to off-site links. Well, no, on-site in order to do the first round of crawling. Then I'll be looking for off-site links as a later part of the project I'm working on. But right now, this is the most lightweight possible way to do a scrape. And you can see I had my bag of tricks open so that I could just tell where to load the key off of the drive so I don't have to show any document keys or anything. I'm using Pipulate here in order to actually push the results into a Google Sheet, but we're going to forego all of that and just start with the very, very simple stuff. We're doing URL stuff or HTTP stuff, so importing requests does come first. Work tab all the way to the left. Again, no matter where you are, Control 1 will pop you back there. We're bringing in the requests object, and you'll see that I had done this experiment on the New York Times originally. You could use any arbitrary site for this, and I'll probably use a different one for the testing. But we are going to look for where the request object is actually used, right? So this is fetching something right there. So we just jump right into the business. What do we want to fetch? I guess for the sake of expediency, we will choose the New York Times homepage because I've got that URL sitting right there. It's convenient, it's popular, it's promotion for them. So we now have the R object just sitting in memory. So Python is really easy for this sort of stuff so long as you use, third-party packages to be able to do HTTP for humans. So that's what I'm doing right now for those who are just joining in. This request object I have because it was automatically installed as part of the Anaconda install, which is how I got Jupyter Notebook, this Python code execution environment in my web browser, which happens to be Chrome right here. So as I'm lifting the code up from my previous life projects, what I want to do is HTML content. Ooh, wow. Elegant. So I'm going to grab all the links off the page. This is a really fair starting point. And a strong argument for why we don't use heavyweight libraries, crawl dedicated heavyweight libraries if we can avoid it. You can see I'm about to use BeautifulSoup here, which means I really do need to pick up the import for BeautifulSoup. I'm making it more verbose than it needs to be so that you can see BeautifulSoup is in use. I don't actually think I like that. I think I like just, oh, well, it is from BS4. Okay. No, that's a good way to do it. Remember, you can always re-import libraries under Python. It's not a problem. And I've already set the R object. So this is going to create something. It's a little bit of extra there. We can just put r.text in here and get it down to as few lines as possible, make it actually even less confusing, right? We're using the lxml parser, which is sort of built in. Again, you get it with the Anaconda install. It's one of the most difficult installs to get otherwise. It's the reason we use tools like Anaconda. So a soup object is going to be created, which is a call to the BeautifulSoup method of the BS4 package, feeding in the text of the page we just used using the lxml parser, creating a soup object. Then we immediately call the findAll method of the soup object, looking for all anchor text where there is an Ahref value set. And now we have a object called links. Yep. All the links on the home page of the New York Times. Now it's the entire anchor text with the Ahref, so you can see it's everything on the page. And there's some sophisticated stuff you can do to clean this up. Again, very Pythonic, and again, reasons to not use heavyweight libraries. So I make list 2, list 3, list 4. These are series of cleaning up, and I can see what each one does. This first one takes out anything where if it has an Ahref attribute, and the Ahref attribute is not just equal to the root of the site, and the Ahref attribute is not equal to just a hashtag. So that's going to be our first step. Now you can see I'm using URL join, so I will need to get the URL join library. I'll grab it right along with URL parse here, which I'll be using in a moment. And I'll keep that up there just to remind you how ugly the first object we fetched was. Let's see, I'm just going to add a few boxes underneath to push up what I'm coding here so you can see it in the middle of the screen. You still have links there, which is this object up here. Remind yourself of that like that. But now I'm about to use some of my code from a earlier project where I take out everything where the Ahrefs have all that ugliness. Links 1 equals that. And I'll put on the same line links 1, which is Jupyter Notebook's way of saying, oh, scrape is not defined. Okay. Join scrape. URL join. Oh, it was, I see what I'm doing. That is the base of the domain so that I can unrelativize the URL. So I set scrape for scrape in. Oh, it's for scrape in list. Okay, so I'm working through a list of URLs. Yep, I'm working through a list of URLs. I've edited out one there. And I'm going to find let's see, join in URL join scrape. Oh, and okay, I think I'm going to build this up from scratch a little bit because URL join scrape for X, because this is quite sophisticated here. Before I jump to something so sophisticated, X for X in links is the heart of that. So when we have something like links, like above, you can always immediately say X for X in links, and that's list comprehension. That's the same thing as saying that statement above. If I executed that, it would be that. But now you've exposed internals. So these are making evaluations in links. These are making evaluations that are pretty much independent of what's going on at the beginning with the URL join. So I can put that on right there and take a look at the first thing it's doing. So it's cleaning up that list. But instead of just using X for X in, I'm doing URL join. I'm doing this little bit of trickery here, which is just, joining my original URL with the Ahref attribute. Okay, now I see, and I'm glad I'm doing this because it lets you folks follow along a lot better. Let me make sure I'm still streaming. Yes, I'm still streaming. This is all worth it. Okay, so I just do that and just put the original URL in there because URL join is smart enough to know to do that. So I'm just going back to the original line that's just right down here. I'm reproducing it, in fact, but this time I know what I'm doing a little bit more. Links1 equals, and now I can get rid of this, which at that point is identical. Boy, this must be painful to watch. But I just need to put that original URL that seeded the query. That's what scrape is. I could have used a variable for it, but by putting it here, you will see how this all works. There. Here are all the on-site URLs from the New York Times homepage. And you can see how many are coming back. So what our plan is really is to crawl every on-site URL. So that's the first thing. One, we'll get a list of all URLs from a page. Two, make all the links. I think I took care of making them all absolute. Yeah, that's what that command did, of course. Make all the on-site links absolute. Okay, so we revisit past life. We see that was link 1. Now there's a link 2 step. Link 2. Oh, I guess that was the link 2 step. So we're up to here, the link 3, list 3. So, okay, links, list. Okay, my terminology changes a little bit, but we'll clean it up as we go here. X for X in list 2. So as you will see, it actually just uses what we just created and does another one of those parsing things, another one of those list comprehension things. If URL parse netlock equals my domain. So that makes sure that it's on site, and URL scheme equals the same scheme as the site. It keeps it on the same protocol, so it's not bouncing between the secure and non-secure version. So it is time now. This is just ugly. I'm just gonna need to look at that anymore. But now I am going to use a variable name because we referred to it so many times. Remember the fetch, the actual going out and fetching the code of the site is only occurring in this line, so as long as we don't re-execute it, it does not execute again. And so we're not doing anything on the site. But let's call this site equals. Now, I'm not re-executing it, mind you. It just means I can use site over and over. Now I can re-execute that one, no harm in that. I won't re-execute this one, but now this gets to use the word site here. And use word site here and here. And so now I'll have a my DOM and a my scheme. I'll get rid of where this prints out. Trust that it's in memory there. But I will show you what my DOM holds. Right? I'll show you what scheme holds. Right? So now it's going to make a lot more sense when I go links2 equals. Remember, we start out with our first list, links1, put square brackets around it, and go X for X in. That's the same thing as saying just links 1, right? So there's links 1, follow that stuff. If we do that, you'll see it's the exact same thing in links 2 as it is in links 1 at this point. It won't stay that way for long, but point being that X for X in a list inside square brackets is the same thing as just the list itself. And you can start to apply logic around there for list comprehension. And you can see the code is still so minimal for what we really are pulling off. This was just to show you those two values. Now we start to make it clear the refinement of the list. And it's always nice working off of past projects, which are the best that you have done on that work to date. So list 2 equals, so I'm going to have to change that to list 1 in there, I believe, because X for X in links 1, right? I'm just replacing this all out. But whereas it's list 2 for us right now, it's links 1. Make sure there's nowhere else I have to update that. And take a look at links 2. It's going to be all on site and of the same protocol. So can you imagine having so much control over a crawl using one of these? I mean, you do have that much control, but customizability, politeness, and not having to re-hit a site, having your cache stuff local. But now I can visit each one of these pages and do the exact same thing, and resultingly have such a large selection of pages that you have an exemplary, that's homepage, and one click deep off of the homepage gives you a heck of a lot of links, far more than I think most people give small crawls credit for. So as you see, I'm always, cleaning up. So my Python notebooks are always easier to look at, only keeping isolated things that I don't want to keep re-executing. There's no harm in re-executing these. Those can go in the exact same code block there. We get rid of that. And the notebook just keeps looking better and better. And I can just re-execute that. And it just works. So this is a crawl. This is a one-page crawl. Let's put that above here. Up there. Executing a one-page crawl. That's all it is at the moment. In not too long, it's going to be significantly more than that. But that's enough for a streaming session, I believe. Let's do our typical cleanup, because this is Linux, Python, Bin, and Git. Make all the links absolute. 3. Make all the links on site. And make all the links. Let's break this into a couple of steps here, right? Make all the links absolute on the site. Same protocol. Okay, so that's mission accomplished there. We're doing this in this repo, so if we do git status, you'll see that new file's added. Git add crawl. Git status, you'll see it's added, right? New file is there. Git commit. Added crawl notebook. I'm not 100% consistent with how I call notebooks or IPYNBs or all that, but consistent enough to get the idea across. It's a good tutorial. I'm thinking I'm making the best tutorials on this stuff out there. This is, dark matter developer. This is the stuff you don't see every day. People talk about all this, but you see it from me. So if you're following along, once again, this work can all be found on github.com/McClevin/Python SEO. Easy enough, right? And there's the one I just added. When we visit it, it renders with the notebook viewer, NB viewer. It looks really great on GitHub. I might control my line lengths to get better wraps and stuff. That's one of the things about list comprehensions. It lets you start to build really long lines that you can understand, but they can become hard to debug, and they have line wrapping and PEP8 issues. So there's a real balance to be struck. There's some question as to what the most Pythonic way to do this stuff is. Complex list comprehensions, or you can break, because there's square brackets and stuff. You can actually break this, and people have all the styles for doing that. But now you're into the world of arbitrary styles, which is, anyway, this is a good place to stop. One page crawl, Python, that much code for people who have Anaconda installed, because that gives you this for free with the Anaconda install. That gives you this for free. And this is just a list comprehension, stupid data trick. So thanks for joining my stream. Hope to stream to ya again soon. And don't forget to follow. Boom, 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 boom.